All right, so if you take these two functions here, a log and an exponential function, we've talked about the exponential functions already, those are inverses of each other. And so if you kind of go all the way back to when we were dealing with inverses, remember in an inverse, bless you, if you embed or take a composition of functions of two inverses, you're always going to get the value x, which means if we did either of these functions or composition of functions, that you'll get the value x. So log a of x is going to be a value x. Okay, so these are inverses of each other. Okay, so what we're going to start, or what we're going to look at on this is, again, basically this logarithmic form. It's just another specific relationship that exists. Okay, and there's a couple different things before we get into the functions of these. And that is, you can always convert between two different forms, either the logarithmic form or the exponential form. So part of what you're going to be asked to do is make that conversion. It's really easy. Okay, so here's the conversion. Okay, so if you take something like this, okay, so starting with the log, the way that you convert into an exponential form is the following. Okay, so the way that this is read is this is log base 10 of 1,000 equals 3. Okay, so this is referred to as a base. Okay, and so when you convert to exponential form, use the same thing. This becomes your base. So the exponential form for this is a base of 10, and then you're just going to kind of go in this circular form. You take to the power of whatever the log is equal to. So 10 cubed, and then set that equal to. So this is to the power of. And then this is equal to. Right? And so 10 cubed is equal to 1,000. That's the exponential form. Okay? So you can go back and forth between the log form, the logarithmic form, or the exponential form. Okay? So if I gave you something like the following. Okay? So if we take, or as long as it's greater than 1. So if we take this, or as long as that base is not equal to 1, if we take log 2 of 1/8 is equal to -3. Okay, what would be the exponential form for this equation, this function? Yes. Good. And so as you see, I mean, it's a true statement too, right? 2 to the -3rd. The negative moves the base to the denominator, and then you cube it. 2 cubed is 8. In the denominator is 1/8. So not only should you be able to translate this very easily, it should still make sense to you. It should actually be consistent equation relationship. Okay. You can do it in the reverse process as well. You can move from exponential form into logarithmic form. So if I asked you the following, or if I gave you the following form. Okay, what would be the logarithmic equation to relate this? 4 to the 0 power is equal to 1, which we know is true. The base of your exponent is the base of your log. So you'll say log base what? 4. And the base of your exponent is the base of your log. And then what goes inside? So here's our base. Okay, when you set your equation equal to, okay, if you look at the way that we transform this, here's our base, okay, and then it's equal to whatever the power is. So what is this whole thing going to be equal to? 0. And then what you set your exponent equal to is really what's inside your log. So this value of 1 is inside our log. So log base 4 of 1 is equal to 0. So that would be the exponent or the logarithmic form of this exponential form. Okay, let's do one more example of converting back in this direction. Okay, so if you take the following. Okay, what is 5 to the first equal to? 5. Okay, see if you can write that in logarithmic form, please. Okay, so when you set it up, it's log to the base of 5. That's the base of our exponent. Okay, whatever our power is what we set the log equal to, so we're going to set it equal to 1, and then whatever our exponent's equal to is included inside of our log, so we get 5. Now, does this make sense? 5 to the first is equal to 5. Yeah, so it's consistent in that respect as well. Okay. Right, these last two examples show a specific set of properties that are true for logs, and that is, and logs and exponents. But the first one is anytime you take the log base anything, and I'll just call it base b of 1, and that's always going to be equal to what? If you think about the exponential form of this, b to what power is always equal to 1? 0. So this is a generic or a very generalized specific form. Log base b of 1 is equal to 0 always. And then the other consistent one is when you take the log base b of whatever your base is. Again, b to what power is always equal to b? 1. So that's always going to equal a 1. So looking at those two, be really consistent. Again, any log form, b can never equal a 1. Okay, everything else, you're good. It's a positive, as long as it's a positive number.